Hi once again, and welcome to the TaskGen Tutorial Series. So TaskGen is an LLM-based agentic framework building on strict JSON. And today we'll be covering tutorial 1, which is how to use the agents of TaskGen. This is a very fundamental and important tutorial because it teaches you all the basics of how to create your own agents, how to equip the functions, and so on. So let's start. So in order to use agents, what you need to do is first install TaskGen using TaskGen AI. Then import the modules from TaskGen. Okay, and start with your API key if you are using a closed source API. You can put your API key. Here we have OpenAI API key. Then we define the large language model, which takes in the system prompt, takes in the user prompt as a string, and outputs the LM response. So typically the system prompt will be something like, you describe what you want the large language model to do, like you are a classifier to classify the sentence, the sentiment of a sentence. And the user prompt would be like the user input, which is like the sentence itself. And you can see here, like it is a hot and sunny day, the output is neutral, all right? So first we go to agent basics. So we will go straight to the example. So the agent itself takes in typically two main parameters. First is the agent name and the agent description. So the agent name in this case is like helpful assistant, and the description is you are a generalist agent. So you can change the name and the description, and the behavior will change accordingly. Then put in the large language model itself by putting LM equals to the LM. This is the function that you have created earlier. So after that, we can see the agent status at any time of time by putting my agent.status. This is meant to be like, Keras, you can see like the progress of or you can do the summary of your model and so on. So this is designed in that kind of guideline. So you can see we have the agent name, a helpful assistant, the agent description, you are a generalist agent. The functions are use LM and enttas. So these two are the default functions that are defined every time we set up an agent. Okay, use LM will mean that just use an LM to solve the task. End task will just mean end the task. So that's when the task is done. Okay, it's deemed done by the agent. So we have in the shared variables, this will be covered in a separate tutorial later, where you can access any variable that your functions output to and so on. Over here, we have the agent itself as the shared variables, so that if you have functions, you can change the agent's parameters from this variable itself. Right, so we have other things like what the agent's task is, what are the subtasks that has been done, and whether or not the task is completed. So what we can do now is we can run something. So as a good practice, just reset the agent each time you run a task so that the earlier task doesn't affect the current task. So here our task is like we want to give 5 words rhyming with cool and make a 4-sentence poem with them. So the first subtask, so it does using something like a React framework. So first, it will see like what has been done in subtask completed, which is basically this dictionary here. And when it sees that, oh, nothing has been done, then it will try to think about what needs to be done, what's the next step it needs to be done to get the task done. So this is very efficient compared to like if you're using AutoGen, the conversational frameworks, because there's no conversation here at all. We have a task, a goal in mind, and we are just trying to think using a chain of thought approach, how best to get there? What next action should I generate? So here we generate that, okay, the first subtask is find the 5 words that rhyme with cool. And here the LM has been selected to run the task, and the 5 words that the LM generated are school, pool, tool, fool, and rule. All right. So the next step, it sees that in the subtask completed, 5 words have already been generated. Next step is to compose the poem, and that's what it does. It composes the poem. And the poem is here. In a bright and lively school, and so on, it ends with jewel. So the 5 words have, and lastly, after the poem is generated, it knows that, hey, the poem is generated, I should end the task, and it ends the task. So we can see the output of the task. You can see at each time step, you have the output by the LM. If you are using functions and the function call is done, you can have the output of the function in this output as well. Just need to do like this, output equals to my agent.run, right? You can get the output for each step here, right? You can then see your agent status again. You can see that, oh, these are the tasks has been updated to this. Give me 5 words rhyming with cool and make a 4-sentence poem with them. The subtask has been changed to whatever has been done. So here we have 5 words rhyming with cool and we have 4-sentence poem and so on. The maximum number of subtasks the agent will keep trying until it ends is 5. Okay, but you can always change the max subtask by just calling the max subtask variable. When you define the agent, you can set it to be like 10 or 20 and so on. 5 is a default that I normally use because most tasks will get done in 5 steps. Okay, so we can, compared to like other frameworks, like LangChain React Agent or Crew AI, I try not to do reply user as one of the steps. Okay, this is because, sometimes even though we haven't finished everything, we can still have useful information to reply the user. So, we shouldn't just give up just because the agent doesn't call the reply user. What instead I advocate is that you just call the reply user each time your task is done. And you can see that over here, we replied the user, hey, these are the 5 words and these are the 4-sentence poem. So, you could even ask something even more specific, like where's the pool? So let's just ask this. So it's like a question answer bot. So you see the pool is mentioned in the context of a lively school where children gather and splash. So you can see this is correct. So essentially by having this reply user, you can use whatever you have generated for your tasks and use it as a QA chatbot directly to talk to that the user can query and so on. So this is very, very flexible. That is why the subtasks, we don't have a reply user. We want to make this reply user very, very generic. And it uses all the information that the agent has already gotten in the subtask completed to reply the user. All right, so we can see the status of the agent right now. You can see that the subtask is like, hey, generate 5 words that rhyme with cool, compose a 4-sentence poem. And you can see that once we reply the user, we also store this in the subtask completed so that, we keep track of what the user has talked to us. So this is something really cool. Okay, if you are trying to use this as a chatbot, I recommend you to check out tutorial 6 because there's a specialized chatbot in the conversation class defined for that. Okay, but this can function as an early chatbot if you just want limited interactions, like 1 or 2 interactions with the user, no problem. This can be done for the chatbot. Next up, we can see like what are the functions used for the agent by using print functions. And you can see we have 2 functions for this agent. One is use LLM, and this basically is used when no other function can do the task, right? And we have end task is basically just ending the task, all right? So what we can do is we can actually run a separate task as well. So we can just reset the agent. Okay, maybe it's best if I show you what happens if we reset the agent here. And I show you what happens to the status of the agent after I reset it. So you can see after I reset, agent name, description, and functions remain the same. Tasks, subtasks, and is task completed all get resetted. All right, and we can see what happens here now. Now we do a different task. We do 5 words rhyming with task and make a 4-sentence rhyming with them. And you can see this is all done correctly. And you can see the output here. You can also reply the user and so on. Right, so let's suppose now, you want even greater control for your agent. You don't want to let it run all the subtasks one by one by itself. You want to make sure that each part of the subtask you can control separately. And over here, this is the beauty of TaskGen agent. Actually, the structure is exactly the same. So like, for example, you have this number expert, you are great with numbers. The task itself now you just change to list me 3 random numbers from 1 to 50 and give me their sum. So you just need to specify this num subtask equals to 1, all right? Or you can put 2 or 3. This means that you run only for 1 step. So you can see that after we run this for 1 step, the first step is just generate the numbers 1 to 50 and give me their sum. Okay, so actually generated everything already. So no biggie. I mean, sometimes it treats this whole thing as one single step. Okay. So as long as like you do it like that, you can see the output here, and then you can do whatever filters you want and so on, rule-based stuff. You can do it from here. You can see now the output is we have generated 3 random numbers 1 to 50 and calculated their sum. So we can run again, and this time around you should already see that, hey, we are done. All right, they already know that, hey, I've already gotten my sum, why are you asking me to do again? So the output is basically the same thing as the first one, because like nothing has changed. We just ended the task. And then we can see that, you know, after the task is completed, we won't do any more steps again. All right. So this is a really cool thing to like step through your agent one by one. And you can just do this by putting num subtask equals to 1 when you call the run method for your agent. Now the interesting part comes in, like what if you want to put tools, all right? And how do you do tools? Okay, to do tools is very simple. What you need to do is to define a function. Okay, so this function, if you remember tutorial 0, this is called an internal function where we will use the large language model to generate something. So in this case, for sentence style, we have an object, an entity, and emotion as the input variables, and we output the sentence. And you can even set the function name to be this. Okay, if you don't put the function name, it will be auto-generated for you. So let's put the sentence style here. I mean, if you want to see what happens, you can even print out what sentence style is to see this is the description, the inputs in a list, and the output like that. Okay, output is a dictionary, right? This is the JSON that we'll be using strict JSON to generate. Then this is the beautiful part. All right, if you have any external functions you want, you just simply write your Python function here, put in the type hints accordingly. Make sure that your docstring here contains the input variable here. And you can see that we can straight away like use this function and put it directly into the agent itself. Nothing else needs to be changed. The agent itself will convert it to a function class directly. So we can just simply call the assign functions, and we put in the list of functions here. And if you look at the agent's functions, you can see that this is the internal function we have. Okay, and this is the external function with the description all converted to you automatically. So very simple. Define a Python function, put in your type hints and so on. Okay, in your docstring, just make sure to mention all the input variables you want the LM to generate. And there we go. Everything is done. Okay, so then we can use this thing to, run a task. So for example, we want to convert maybe the 1001 to a number, and then generate me a happy sentence with that number and a ball. Okay, let's see what happens. So first, we use the binary string function to convert it to a 9. And then we use the sentence with object entities emotion function to use 9 colorful balloons and a ball and happy. And you see the answer is, I have 9 colorful balloons that make me so happy, feel so happy, just like a ball bouncing in the sun. So essentially, based on this task, is able to map to the equip functions automatically. Pretty cool, right? So you can see this is the status of it. And if you want to reply the user, you could just do reply user, and based on what you have generated, the agent will say, hey, I've converted the binary string 1001 to the number 9. Using this number, I've generated this sentence. And yeah, this basically, describes the agent output to the user. I mean, if you want something more specific, you can change what is in the reply user. You can say output, or I already done it here, output only the sentence. Okay, and you can see that this is the sentence itself. Okay, and if you look at the status of the agent, you will see that you have all the tasks in a very concise way. So you see there's no thoughts at all. Over here, it's just simply the subtasks, the name and the input variables and the output. And you can see the interaction with the user is here as well. So if you don't want the interaction with the user, we can just put, there's basically a way to make sure that, when you reply the user, you don't store it in the history. So let me just refresh my memory by going up. Stateful equals to false. So let's go here, stateful equals to false. And, if you use this wouldn't be added to the subtask. Now, if you actually, just for your curiosity, if you have the same subtask name, this is what will happen. We will have subtask bracket 2. So don't worry, you can call it the same name and the LM will know you have done it twice. Yeah. So this is really cool. Like, this is how you can see the subtask completed. For those who are interested to like directly modify the subtask completed, it is a dictionary that you can access using this my agent.subtask completed. And you can see that all the values, which is the subtask name, and the function inputs, and the output is the function output. And I've just recently added this feature. If you want to display your previous thoughts, observations, and so on, you can just put my agent.thoughts, and every single observation, thoughts, current subtask, function name, function input, all this will be displayed to you, and you can do whatever you want with it. So like if you are using TaskGen to go through a list of steps, and you want to let the user know the thoughts of the agent at each step, simply reference the thoughts variable, and everything will be made known for you there, right? So this is a new feature. So have fun using this. So there's another way to use functions, and that is to ask the agent to select the function for you, and after that, use the function itself. So you can see that we have this myAgent.select function, and you can give it a task, and out comes the function name and the function parameters. All right, let's just run this. And then basically you can see the function name is here, sentence with object entities, and the function params, the TaskGen will fill in for you, like object is bell, entity is dog, emotion is happy. And when we use the function, we just need to call myAgent.use function, put the function name here. In this case, the function name is this sentence with objects, entities, emotion. Put the function params, that's also generated by this select function. And then you can put whether stateful is true or false. So stateful is true means, you update the subtask completed. Stateful is false means, you don't update it. So yeah, you can see that we can basically do the steps of the agent directly ourselves by selecting the function and running it and using it. Okay, you can see that there are other functions you can use, like for this task, what's the decimal representation of 101, it uses the binary to decimal function. And like for this one has nothing to do with the earlier. Okay, sometimes it uses the sentence with objects entities, which is possible also, like if you use like exercise and so on. Let's try again. So okay, this one I wanted to use LM, so maybe let's make it a bit more explicit. So now we use the LM function, and you can see that yeah, it generates benefits of exercise and so on. So this is how you would use the function directly, just by selecting a function and using a function. Okay, so far I haven't really had to use this in production. This is just, if you really want to go in the nitty-gritty details, we provide this for you as well. And most of the time, what you really need to do is just to do, maybe even if you want to step through it, you just need to run the function like this, and you run it one with num subtask equals to 1, and that's good enough to do the, do the output checks and everything. All right, let's move to async agent. So async agent, credit to Prince here again. And this basically makes the agent run faster because you can do multiple processes at one go while waiting for one process to finish. All right, so this is async mode. And first up, we need to define an LM async, which is basically the same as an LM, except that your LM is an asynchronous function. So here we use async OpenAI. You can use your own LMs that are in asynchronous mode. Okay, use an await over here because it's an async operation. And essentially the output is still a string. So input is system prompt, a string, user prompt is a string. The output returns also a string. Okay, so the difference is now we need to use async function instead of function. And everything is the same at the start. Just make sure that your LM is the async version. All right. The external function, no change, because unless you are having an async process inside, then you should define your external function as an async function. Okay, if not, no change, you can just use your normal function. Okay, when you define your agent, you use async agent. Okay, because this helps to cater for all the LM calls to have an await in front of them. All right. So then we assign the functions, the same functions, sentence style and binary to decimal. And you can see the output here. Instead of the normal one, we had to use await because it's asynchronous. So first we convert 1001 to a number, and then we use 9 ball and happy, and you can see the answers. And we run the await, my agent.reply user, you can see the binary string. This has been converted, and the sentence is 9 colorful balls bouncing around. So this is correct. And you can even see like my agent.status. This one don't need to use await because there's no asynchronous thing in printing out stuff. So you can see this is what we get here. Exactly the same as the synchronous version. So I highlight again the difference in asynchronous version is your LM needs to be defined in async mode. All right, use async function and use async agent. Okay, external function, no change. Okay, if there's asynchronous stuff, you define it as an async definition. All right, so next up, we can also do single function calling like this. So we can just select the function using await and use await also when you use the use function. Everything should be the same. So you can see that we use the entities function and we have the parameters generated, and yep, we could have the sentence here. The bell rang loudly as the dog barked in excitement, which fulfills this. I'll put the sentence with bell, dog, and happy. So yeah, that's more or less the tutorial for today. There's also a way to save and load agents in code. This one I'll run through with Hardik separately. But essentially, TaskGen is very simple. I just run through again. Install TaskGen AI, put the necessary imports and API keys needed. Define your own LM here with a system prompt, user prompt, and the output as a string. And then simply, just use your agent with the agent name, agent description, and your LM here. Okay, if you want to define a max subtask, you can do it here as well. And if you want to, equip your functions, you just use the assign functions here that you see down here. You can just assign whatever functions you want. And these functions can be either the internal functions using the function class of TaskGen, or you can just use an external function like this. Just put your type hints and everything, and put the doc string that contains your input variables, and you are good to go. As easy as that. So, you can easily define a workflow just like, one line, 2 lines, and then you just do agent.run, 3 lines, and you're done. So essentially all agentic processes can be done in 3 lines, or I mean, the basic ones can be done in 3 lines. And that's what makes TaskGen so powerful. I'm keen to see how you use it for your own tasks. And stay tuned for more. We will introduce more features of TaskGen in the next few tutorials. With that, signing out.